Hello and welcome to Algebra 1, Chapter 11.9, and today we're going to discuss solving rational equations. So, once again, remembering that word rational means fraction, so these are going to be equations that have fractions in them. My suggestion to you on how to solve these is to get rid of the fractions because that will make it much easier, and I'll show you how to do that. So there's three examples that I want to walk through. The first one is x over x minus 5 equals x plus 4 over x minus 6. What you have here is a fraction equal to a fraction. This is called a proportion. Okay, whenever you have that kind of setup, you solve proportions by cross multiplying. So the more difficult thing here than just when we talk about proportions in class is that you have lots more x's and in this case several binomials. So to solve a proportion, cross multiply, you multiply going this way, so we're going to have x times x minus 6 equals, then you multiply going the other way, and that is going to be x minus 5 times x plus 4. So you just really have to be careful to multiply correctly. So we get x squared minus 6x when you distribute. On the other side, we're foiling, so we get first, outer, inner, and last. And we can combine like terms. And so what we've ended up with then is a quadratic that you're going to need to set equal to 0 and solve. And in fact, when we go to set it equal to 0, our x squareds are going to cancel. Yeah, so we'll just do that at the moment. So equals, that cancels, you get 5x minus 20 equals 0. Add the 20 back over. If I hadn't done that in the same step, I would have gone ahead and not added the 6 over. Divide by 5 and x equals 4. Now, because you're dealing with fractions, you have to check for extraneous solutions. Extraneous solutions are answers you get that you've done all the math correctly, but when you plug them back in to the denominators, they're going to give you 0. And remember, you can't divide by 0. So if I plug 4 into this first side, I'm going to get a negative 1 for a denominator. And if I plug 4 into the right-hand side, I'm going to get a negative 2 for a denominator, both which work. So our next example is going to be one that's not a proportion. So if we have 2q minus 1 over 6, minus q over 3 equals q plus 4 over 18. So not a proportion because I have multiple fractions on one side. The way you solve this is you're going to multiply the entire equation by the least common denominator. So we're not actually going to make a least common denominator, but if you did, if you were to give everything here a common denominator, what would it be? Well, I hope you said 18. It's going to be 18. Remember, 18 is on top, 18 over 1. We're going to multiply everything by 18. So what you get is 18 over 1 times 2q minus 1 over 6 minus 18 over 1 times q over 3 equals 18 over 1 times q plus 4 over 18. Now, this is going to be a step I hope you can skip at some point. But what you need to see is, before you ever multiply fractions, you should be reducing your fractions. So 18 and 6 reduce to a 1 and a 3. 18 and 3 reduce to a 1 and a 6. And 18 and 18 both reduce to 1s. And that leaves you then with 3 times 2q minus 1 minus 6q equals q plus 4. And now I have this very nice equation with no fractions, so no denominators. I'm going to distribute. Oh, and really nicely, those q's on the left-hand side are going to cancel. If we move our q on the right-hand side over, we're going to get q equals negative 7. And because there's no variables in the denominators, that means q can be anything at all because everything will work. Thus, q equals negative 7. So our last example of the day is going to involve some denominators that are not just numbers. All right, x plus 7 over x squared minus 9 minus x over x plus 3 equals 1. So we're going to solve this the same way. You're going to multiply by the least common denominator. But to get the least common denominator, all the denominators must first be factored. So we need to factor x squared minus 9. And it so nicely is a difference of squares, so it factors into x plus 3x minus 3. And so your least common denominator is a combination of all the factors in the denominators. And so we're going to multiply this whole thing by x plus 3, x minus 3. And if you didn't get it, you'll see why here in a minute. So this goes to everything. And we can do what we did a second ago and write it all out. Like I said, I hope this is a step that eventually you can bypass. But if not, that's okay. Sometimes it's better to see it and get it right than to not see it, try to take a shortcut, and get it wrong. Okay, so all I did was distribute that x plus 3x minus 3 to everything, and then if we simplify or reduce before we multiply, we get x plus 7 minus x times x minus 3 equals, I'm going to go ahead and multiply that back out. It's x squared minus 9. I know that because it came from up here. Okay, so again, no denominators should make it easier to solve. Okay, make sure when you distribute that x that it's a negative x, so your signs are right. This is a quadratic. Let's go ahead, combine like terms. I'm going to run out of room, but that's okay. Squared minus 9. All right, so we're going to add x squared to both sides. We're going to subtract a 4x from both sides. And we're going to subtract a 7. And I'm going to write it up here at the top. This is going to be 2x squared minus 4x minus 16 equals 0. Since everything is divisible by 2, let's divide by 2. That will help solving it. And then we're going to factor. This would be minus 4 plus 2. And so our answers then are 4 and negative 2. And if we look back over here, can I put a 4 and or a negative 2 there? Yes. And can I put a 4 and or a negative 2 there? Yes. So those are our two answers. If you have an answer that is extraneous, just mark it out. If all of your answers cross out, then write no solution. So let me know if you have any questions. If not, I will see you in class. Have a great day.